Welcome to IDA's video channel. In this video, I'll show you how to run the analysis with the flow control valves. In the previous exercise, we ran the analysis of the pipe network connected to an existing network or the supply node, but unfortunately the flow was too high and we wanted to decrease the flow and the velocity in a system. For that purpose, we will introduce flow control valve. We have two options. We can add a flow control valve at the beginning, or we can add the flow control valve at the end. In both cases, we'll get a different results, and it depends what we need to achieve. Then you must use the correct option. We will try both, so you will see the difference, so you can make a better decision when you're working on your project. Let's insert the flow control valve right at the beginning. Go to ribbon IDAS, insert structure. If you prefer using extended ribbon, go to ribbon IDAS network edit, insert. Then specify the network name, specify the surface, specify the part. You can type F and select flow control valve. And I want to interpolate the structure depth from the current pipe slope. Then I click OK. And I specify the location. I will select the flow control valve and then I go to structure properties because I want to change the name. I want the name to be flow control valve 1. OK. I also want to double check the names of the incoming and outgoing pipe. The flow direction is from the left to right. So this is an incoming pipe. So I go to pipe properties. And then I will call it P1 in. It's not necessary to rename the pipes, but you will see it's easier later on to see which pipe I'm working with. Then I click OK. And for the outgoing pipe, again, I go to pipe properties. I will use P1 out. OK. And I'm ready to go to pipe manager, or I can use manage and analyze, or pipe manager. I go to structures, valves, flow control. There's a flow control name, and this is very important. The outgoing pipe users often forget about this setting, so you must specify which pipe is going out, and that's why I named them P1 in, P1 out. So it is very easy for me to select correct pipe, but you can always zoom to plan and see the pipe name and select the correct pipe. Then there is a pipe diameter, there's a valve diameter, let's say I will use a 90. Fixed status, what it means, if you set it to none, there is no fixed status and it behaves as a valve. Or if you wish to, it can behave as an open conduit or a closed conduit. In those two cases, it doesn't behave as valve. So if the fixed status is set to none, it operates as a valve, and that's what you want in this case. Then there's a surface elevation, invert elevation, depth below surface. And another important settings is a maximum flow. I will use 20 liters per second because in a previous exercise we got around 25 liters per second, and I want to limit the flow to 20 liters per second. There is also an option to set the minor loss. If you go to IDA's help file, let me go there, I go to documents, then I go to search, Control F, minor losses. Let me go next. This is not the one. So I'm clicking a few times because I want to get to the chapter that explains more in detail minor losses, and this is the correct chapter. In this manual, I'm at the page 1245. It might be a little bit different depending on the IDA's version. And here I have a little bit more details about the minor losses, how they are calculated, what values you should use, and all that. So let me go back to structures, valves, flow control. I will leave it as it is for now. And then I want to run the analysis. If I run the analysis now, I will get an error. Let me show you. I go to Analyze. You can also go to Ribbon Analysis, Analyze. And if I go to report, analysis report, I've got an error because the P1 out contains illegal numeric value because I didn't specify roughness coefficient for this pipe. So I go to conduits, pipes, roughness coefficient, and then I specify the value 0.0015. Then I run the analysis again, normal analysis, okay, and you can see the velocity dropped to 2.037 meters per second, and the flow is 20 liters per second. And let's check the profiles. And here you can see the hydraulic and energy grade line. If you don't see them, you can tick them on. You can also remove some labels, so it's not that busy. I can remove the pipe label, structure depth. And you can clearly see that we are dropping the pressure and then it goes to our tank. If the surface had a hill here, I would have a problem because I would have a negative pressure at this area. So in this case, you're dropping the pressure throughout the system. And in some cases, that's what you desire to do. In some cases, you don't want that. So let's explore another option where we will add flow control valve at the end of the system. Just remember this shape so that it goes down and then towards the tank. Go to ribbon Home. If you want to, you can update results, doesn't really matter. But if you update results, you should see the changes in your hydraulic grade line and energy grade lines, as you can see now. Then I will swap this structure to a junction, or I can delete this structure. I can select the pipe to keep. I want to keep this pipe. And let's zoom to end. And then I will insert structure again. I can use the insert structure command, or in a network edit, I can use insert. Then again, I select flow control valve. It remembers the last settings except interpolate structure depth. Okay, and I will place it in here. Again, I go to structure properties. Then I specify the name. I want to call it flow control valve 2. Okay. And then I want to modify incoming and outgoing pipes. So I go to pipe properties. This is P29 in. And then I click OK. And for the outgoing pipe, let me go to pipe properties. I can keep it P29 out or P30, but I will use a P29 out, for example. OK, it really doesn't matter what naming you use, or you don't need to rename anything. Then I go to Manage and Analyze, or IDAS Pipe Manager, again the same command. Then I go to Structures, Valves, Flow Control Valve, and again I need to make sure correct outgoing pipe is used, valve diameter 90, fixed status none, maximum flow 20. Then I need to go to conduits because there is a new pipe which has a 0 roughness coefficient. I need to use 0.015 and I'm ready to analyze, or I can use a button Analyze here. Then I go to Report, Analysis Report. The report looks good. I can go to conduits and I can check the flow and velocity. And I can also go to Profile and check the hydraulic and energy grade line. And you can see the difference. Now, if I had a hill here, I would probably still have the positive pressure at this area. But I have a higher pressure in the entire system. And then it drops down after the flow control valve and at the tank. And if I want to update results to Civil 3D, I can go to ribbon Home, tick Update Results to Civil 3D, Update, and that should update hydraulic and energy grade lines. As you can see, this is the exact result as I got in Pipe Manager.